Hi, the next function we need to tackle with is reciprocal function, and we will start with this function in its simplest form to explain how it works first, but this function has another advantage. There is plenty of transformations that we can actually use with any function, but using reciprocal function serves as the best example of how they work. Okay, and the function we are going to deal with is y equals 1 over x. Okay, so first thing we should do when we see something like that is to make one restriction. X must be different than 0. So look, the domain of the function, so the values of the arguments in this case are real numbers but with the exclusion of 0. So real numbers without 0. Okay, so let's start with a table and let's see how this function works. Okay, so we have a table x and y. This is going to be a long one. Okay, let's just say that here in the middle we've got 0, and for this 0 we have no value, right? This is what we established at the beginning. We don't know how to divide by 0 properly. Okay, now let me put some values over here. Let's start like this. Okay, so let's start. Okay, let me maybe finish the table. Okay, but let's start actually from 1. Look, if x is 1, y is simply 1. Now, if x is 2, we get 1 over 2. If x is 3, we get 1 over 3. Then, if x is 4, we get 1 over 4. But what happens if x is somewhere between 0 and 1? Well, if I divide 1 by 1 over 2, I need to multiply by a reciprocal. I'm going to get 2, 3, and 4. Okay, so at this moment, we are ready to draw the first half of this function. Okay, we see that when x is 1, y is 1 as well. But now look, as x is getting smaller and smaller and smaller, 1 over 2, 1 over 3, 1 over 4, 1 over 5, y, we get the reciprocal, so we get bigger numbers, 2, 3, 4, 5, and so forth. But what happens to the right of 1, of this point? Here, we are dividing by a bigger and bigger number. So, the values of the function should get smaller and smaller and smaller. Okay, so this is how this function will look like. But this is only first part. Now let's tackle the other one. If x is negative 1, y is negative 1. If x is negative 2, we get negative 1 over 2, negative 1 over 3, negative 1 over 4. Then, if negative 1 over 2, we get negative 2, negative 3, and negative 4. So look, we will get exactly the same shape, but it will be over here. So if I put negative 1 over here and negative 1 over here, the shape I should obtain looks like that. Okay, again, you can clearly see that if I would put a mirror, so if I would draw a line over here with the formula y equals negative x, which would have, of course, here 45 degrees, those two would be mirror reflections of one another. Okay, so knowing this, let's talk about some hidden properties of this function. Look, let's start with what is happening if the numbers here are increasing. Look, if we see that if I increase the number from 1 to 2 to 3 to 4, we are dividing 1 by a bigger and bigger number. As a result, we are obtaining a smaller and smaller number. If I would have here 1,000, I would have here 1 over 1,000. If I would have here 1 million, here I would have 1 over 1 million. Okay, so we clearly see that as x is getting bigger, y is getting smaller, and we are getting closer and closer to the x-axis. Will we ever reach it? No. Look, it doesn't really matter how big the number is. We will still get at least some number above. Of course, we are saying that in infinity, this function goes for 0, but again, we haven't started limits. So we cannot elaborate on this that much at the moment. But we clearly see that values of this function are getting smaller and smaller and smaller, but they never get to x-axis. And what about what is happening over here? Look, here, as x is getting smaller and smaller and smaller, we are dividing by a bigger, in absolute terms, negative number. And look, we are also getting closer and closer and closer to x-axis, but we can also never reach it. This is why we might think that x-axis contains a line called an asymptote, which means that the values of the function are getting closer and closer to this line as we go, in this case, either into infinity or negative infinity, but they will never reach this value. So the formula for our asymptote here is simply y equals to 0. So now let's think what is happening as the values of x are getting from negative 1 to 0. Look, what is happening now is that values of the function, we are dividing by a smaller and smaller and smaller number. And as a result, we are getting a bigger number. Because look, if I'm going to take 1 and I'm going to divide it by 1,000, I'm going to get 1,000, right? If I'm going to divide by a million, I'm going to get 1 over a million, I'm going to get 1 million. A billion, a billion. Now, the thing is, we are getting closer and closer to 0, but we know we cannot divide by 0, right? So again, we can use the trick with the asymptote. We can imagine that there is like an invisible line going through vertical axis, and as values of x are getting closer to 0, from the right hand side we are getting closer and closer to y-axis, but we never reach it. And the same is over here. Look, if values are getting bigger and bigger, but from negative 1 to 0, the values of the function are getting smaller and smaller and smaller, right? But they never, so as they get closer, they go lower and lower, and they get closer, and the function, the graph, getting closer and closer to vertical axis, but it never reaches it. Now, what would be the formula for this asymptote? Formula for this asymptote would be x is equal to 0. But remember, we can think about this asymptote as a function, but we cannot do about this line. This line is not a function because for one x, we should have only, for a given x, we should only have one value of y. And this is not the case over here, where for x equal to 0, you see we have any number of the values of y. Okay, so look, now let's see, now that we know how this function works, we can actually use it to elaborate on different economic and mathematical transformations we can perform with this function and see the results. And I believe that this should speak to your imagination on how the functions work. Okay, so this is the function we've got. Now, what is going to change? Look, imagine the function we are going to do now is y. I hope you can see it over here. Y is -1 over x. Well, we already talked about this transformation, right? It's not very problematic, but what we need to do, we need to change any number to a number with an opposite sign, right? We would get -1 over 4, -1 over 3, -1 over 2, -1, -2, -3, -4, still nothing. 4, 3, 2, 1, 1 over 2, 1 over 3, 1 over 4, right? So, what is going to happen? Look, all the positive values are now becoming negative. And all the negative values are now becoming positive. Of course, this is a mirror reflection of this. This is a mirror reflection of this. Okay, so this thing wasn't that complicated. So maybe let's try something new. And something new is going to be absolute. Let me check if everything can be seen over there. Yeah, absolute value. What is absolute value? Absolute value is a function. We write it as 2 bars and x in between, and this function is equal to x if x is bigger or equal to 0, or -x if x is smaller than 0. So look, what does it do is that it changed all the negative numbers to positive numbers, but it keeps positive numbers in the same form. Okay, again, let's see now what would happen with our reciprocal function if I want to draw a function y equals absolute value of 1 over x. Okay, so what's going to happen now? Well, all the positive numbers should stay the same. Y 1 over 4, 1 over 3, 1 over 2, 1, 2, 3, 4, nothing here. All the negative numbers should become positive. Okay, now we can put this on the graph, right? This is our original function, 1 over x. 1 over x and a mirror. And so what should be happening over here? First, this part, as you see, has not changed at all. So we can color over it because this part is not changing. But all the negative numbers are becoming positive. So the new function looks like that. Okay. So this transformation wasn't that much problematic. Let's try something different. Okay, now let's see what is going to happen if I'm going to take the same function, the same reciprocal function, and I'm going to make just one tiny adjustment. What is this tiny adjustment? Well, now I will have a function y equals 1 over x plus 2. Let's just say we're going to do this one in Greek. So, as you see, we can treat this, we've added a constant 2 at the bottom. So, what is happening is that now every value of the function that we had originally will be higher by 2. So, if we're going to make a table out of it, what I should do here is to add 2 to every number. Of course, here still nothing. Here we have 6, 5, 4, 3, 2 and a half, 2 1/3, 2 1/4. And over here, -2, -1, 0, 1, right? Then we will have 1 1/2, 1 2/3, 1 and 3 over 4. Okay, so let me just erase the previous function. And now, if this is the original, how should I draw the new one? Well, there's a lot of possibilities, but of course we want to get the easiest. And look, remember that over here there is an invisible asymptote, right? It's at 0 for the original function. But now, values of the function are not going closer and closer to 0. They are getting closer and closer to 2. And the same happens over here. Look, we are getting closer and closer to 2. So the easiest way to graph the new function is to draw a new asymptote on 2, and then draw the function like that. We are drawing exactly the same function as here, just 2 points higher. So we can treat this as our old x-axis. So look, what do we get from this? The general rule is that if I have any function like y equals f of x, if I add to it positive number b, the function will go up by b, right? It will be b units higher. Now, what if I would be subtracting the positive value b? Well, we can imagine it quite easily that now the function will be b units lower. If I would have minus here, I would just draw an asymptote over here at the negative 2. I would draw a function like this. Okay, and this gives us the first transformation. What happens if I add a number, a constant number, to a function? Okay, I don't think that was that complicated, so let's go to another case. Okay, let me just erase this whole thing because it's becoming really hard to see what's on the graph. And again, our starting point is y equals 1 over x. Okay, so I'm sorry, but we will continue with this in the next video.